Lesson 9, Part 2, Question 1. Determine the null and alternative hypothesis. So the null hypothesis is 529 because that is what was previously accepted to be true, or what was assumed to be true to begin with, that it hadn't changed. And so that is 529 because that's what it says. In the second to last sentence it says the scores in the GMAT in the past have a mean score of 529. So we're going to assume that it has not changed. That's our null hypothesis. The alternative is the last sentence. The BYU professor feels now the score has improved within the last couple of years. Okay, so that is why it's the alternative hypothesis is mu is greater than 529 because that's what the professor wants to test. B. Suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of students taking the exam is still 529. Was a type 1 or a type 2 error committed? Okay, this is a type 1 error because you rejected what was true. You rejected the truth. And so you thought that it actually had improved, but when in reality it hadn't. And that becomes pretty dangerous. So that is committed a type 1 error, rejecting the truth. Part C. If the analysis was done at an alpha level of 0.01, remember alpha represents the level of significance, what is the probability of committing a type 1 error? And the simple answer is it's 1%, or 0.01. Your alpha level, or the level of significance, is the probability of committing a type 1 error. D. If we want to decrease the probability of making a type 2 error, would we need to increase or decrease the level of significance? Okay, now, the level of significance, remember, is the probability of committing a type 1 error. So if you want your probability of committing a type 2 error to be low, your level of type 1 has to go up. It's kind of like a balance. Okay, as one goes up, the other goes down. As the other goes down, the one goes up. Okay, so the probability of making a type 1 error is inversely related to the probability of taking a type 2 error. So if you want to decrease the probability of making a type 2, you'd have to increase the level of significance. Question number 2. Design a study. What is the population from which the realtor obtains his data? How did he sample his population? And what is the research question? Okay, so first off, the population. Where did he collect his data? That's your population. So he collected his data from the second home buyers. How did he do that? Well, in here it says he just did it randomly. He randomly selected. In the next question, we'll talk about different ways that he could have randomly selected from his own clients. The research question is the average age of the people buying second homes in his area, is that different than the average age of people buying second homes on a national level? Okay, remember your research question is just simply what you're trying to find out. If you want to find out if body temperature is different, then ask that very question. Is the average body temperature at BYU Idaho different than the average body temperature of humans in the world, or something like that? So it's just what you want to find out. Very simple. B, collect the data. Name at least one way the realtor could have randomly selected his sample. Okay, so there's lots of different ways he could have done this. He could have listed all of his clients in an Excel sheet that numbers them, and then he could have gone to a random number generator and selected a random number and picked out maybe, he said 15. He could have written them all of his clients down on a piece of paper, and then he could have cut up the pieces of paper, put them in a hat, shaken it, drawn it out. Lots of different ways he could have randomly selected. Part C, describe the data. Graph the data on a histogram, sketch the histogram below, or cut and paste your electronic copy. This we're going to do on SPSS. And so if you can see under column 1 or variable 1, I have manually typed in all of the data that's given in the assignment. And what we're going to do with this is we're going to run the test. So you come up here to Analyze, the sixth option from the right, go down to descriptive statistics, and then we're going to explore. Okay, now a lot of times this variable starts over here. So what you do is you just click on it and then you hit the arrow and that sends it over to the dependent list. Now we can hit on our plots and we can choose what we want to see. Okay, so normally it'll start with only the stem and leaf plot selected. But we want to see the histogram as well, and let's not worry about the box plot. So you select histogram, you hit continue, and then you hit OK. It'll bring up a new window that will give you the information that you need. So you can see right here, this is your 15, this is the sample size. And if you scroll down, this is the big box that you want to copy into your document. It has the mean, the confidence interval that we've been talking about. It has the standard deviation of the sample and the information that you need there. As well as if you continue to scroll down just a little bit, if I make this a little bit bigger, you can see the histogram there all in once. Okay, so that's what you want to include for Part C. Part D, check the requirements. Since there are only 15 pieces of data, what we need to do. Now remember, if there are less than 30, and we don't know if it comes from a normally distributed parent population, then we have to make a QQ plot. So we come back up here, and you may have noticed the first time that that was an option, but if not, I'll show you again. So you go to Explore, make sure your variable 1 is in the dependent list, click again on the plots, and now we're not worried about the histogram, but we're worried about the normality plots. Okay. Now at the very beginning we could have selected them both and then just done it in one big bang. Hit OK. So here's the same information that we had before. Here's our histogram again, but also we have our QQ plot. And our QQ plot actually doesn't look too bad, so we can say that we pass our normality issue. State the null and alternative hypotheses. So our null hypothesis is, remember, the status quo, or what is assumed to be true. And we're going to assume that his area is no different than the national average. And so the null hypothesis is that mu equals 47. And the alternative hypothesis is that it's just simply different. We want to test to see if his age group of clients is different than the national average. Now, remember, this is a two-tailed test because we are wondering about both sides. We don't care if they're younger or older, we just want to know if they're different. And so, again, the two-tailed is represented by not equals 47. Part 3, we'll use a level of significance of 0.05. And Part 4, compute the test statistic. Write the formula to be used. Okay, so we're going to be using the z-score here. Now remember what our z-score, let's review what our z-score is real quick. Z is equal to x bar, which is the mean of the population, or the mean of your sample, minus mu, mean of your population, divided by sigma, which is your standard deviation, divided by the square root of n, which is your sample size. Okay, so let's fill in these pieces one by one. As we saw in our Excel sheet, the mean of our sample was 46.93. Oh, excuse me, 46.73. The mean of our population, now remember that's the mean of the whole United States, we know is 47. We know that our standard deviation is 5. And we divide that by the square root of 15, which was the sample size. And when you type all of this into your calculator, you come out with a negative 0.2091 is your z-score. Okay, part 5, compute the p-value. Okay, in order to compute the p-value, we need to come to our normal probability applet, which I'm going to show you a real quick reminder how to get to that. So you go to the BYU Idaho wiki for statistics, which remember is at statistics.byuimath.com. And come to your resources, and then down under statistical tools, you can see the normal probability applet. Okay, now what we have on our normal probability applet is our area, which represents the p-value. And remember, we are looking for a two-sided or two-tailed alternative hypothesis. So we're going to keep both sides shaded, and then plug in our z-score, which was negative 0.2091. Hit enter, and we get a p-value of 0.8344. All right. Part 6, compare the p-value to the level of significance, or the alpha level. Do we reject the null hypothesis or fail to reject? Okay, so let's write this up really quick so that we can see what we're going to do. So before the test, we chose an alpha level of 0.05. Okay? Now, after the test, we found that our p-value was 0.83. Now, our catchphrase, I'm just going to write it one more time, is if p is low, reject the null. Okay, so this is our test. So if the p is lower, then we'll reject the null, but 0.83 is not lower than 0.05. It's way bigger. So we are going to fail to reject. Fail to reject the null. Part 7. State your conclusions in terms of the alternative hypothesis. And this is as it says. We just simply have insufficient evidence to conclude, and then you always just restate the alternative hypothesis. So because we failed, we say there's insufficient evidence. If we had rejected the null, then we would have said there is sufficient evidence. But in this case, we have insufficient evidence to conclude that the mean age of people buying a second home is different in the one man's area than that of the national average. So we didn't have enough evidence to say that. E, take action. What action, if any, do you suggest the realtor take based on your statistical conclusion? Okay, so I recommend he not take any different action than what he's doing. He can continue to advertise to the 47 more or less age group of people.